Well, thank you for joining us today. We're going to start this out. This is our 2026, our combined team meeting. This is where each team is given some time to talk about different things that might be interesting to the other teams also. So this way we can kind of cross-pollinate between the teams and kind of work with each other on what's going on with NRRA. So we're going to start out today with just kind of a little background on my side for NRRA. Again, my name is Ben Worel with the National Road Research Alliance, Executive Director. I work for MnDOT. And then we'll have the team updates and maybe some time for discussion. So my presentation is going to be kind of going through quickly what we talked about at TRB. I know many of you weren't able to attend there, but we did have 80 people in the room, which was great. But let me kind of go through this real quick. This is our structure, and this is nothing new, I think, to anyone, unless there's someone here that's new. Again, but we do our research pays off seminars, we do our team meetings, we do quarterly meetings. This is one of the quarterly meetings that we have, and then we have individual focus meetings for the teams that we have. We did meet at TRB in 2026. I think we had a good meeting there. We did have some new people to NRRA. Lots of good interest in NRRA. It's nice to see some of the research that's going on related to the efforts that we've done in Phase 1 and Phase 2. That was very inspiring to me, at least, to see what's going on there. But we're having our spring meeting. I'll talk a little bit about that later on in the slide coming up. And our website, again, is probably the best place you can find information on NRRA and the projects that we're working on. Again, thank you to the team members. Kind of shows the teams, the chairs that are part of this, from the flexible, rigid pavement maintenance, geotechnical, and intelligent construction. Intelligent construction kind of touches upon all the teams. That's why I kind of threw it that way. But again, also thank you to the associates that are part of these teams. I think it's a nice setup. The executive team is going to be meeting later this month. I need to send out when is good to the executive team, but we'll be talking about some of the planning for Phase 3. But again, thanks for the technical teams. And I think something to think about is like Emil, we started the low carbon working group, and whatever you want to call it now. We still have that available to us. Emil's we'll be talking to you if we want to continue with that or not. There might be a good opportunity to kind of have a place to talk about those types of issues that we're working on, even if it's the sustainability or whatever term you want to call it, politically, not politically. There's still a need to optimize our materials, optimize profits for industry and things like that. So keeping that group seems to make sense, maybe renaming it. But one of my questions too might be is, what other groups might we want come Phase 3? I know Glenn Engstrom's mentioned the idea of having just an associate group. So it gave maybe time for those groups to meet and talk, get one-on-ones with different people. Maybe there's a need for an AI user group. The whole thing of how we use AI, I think some research pays off and things like that we do in the future. It could focus around that. But if you have ideas for other groups, let us know. It's not that big a deal to put something together like that and move forward with that. Again, the structure we had, we're in NRRA Phase 3. I'll talk about the status, but right now we have 13 members. Again, shows the pay structure, the different states that are part of it. Again, there'll be an ICT efforts. Both Georgia and New York has shown interest. They may have not committed yet on the pooled fund yet. And we still expect to keep our associate membership, which is at $2,000 a year. And for the associations, the industries, consultants, universities. We have this fee structure at this time for Phase 3. Again, the same amount for the government agencies. We talked about ICT only has gone up. I think that went up 5,000 instead of 25. It's now at 30. Implementation efforts, if states wanted to put extra money in for implementation, that's something we'll have to figure out as the executive team, the state that puts money in, how they want to utilize it. but there's that option along with additional travel option to go to TRB and other meetings. Then the associate membership will stay the same. So what the status is right now is the NRRA, the pooled fund is approved. It's on the pooledfund.org website. MnDOT has completed the acceptance letter, meaning saying that we've accepted this pooled fund. Agencies now can commit funds to the pooledfund.org through the normal pooled fund process. So if you've promised money, now you can put your commitments into there. So that would put money in the bank, put it that way. MnDOT right now is starting the accounting codes. Now that we have the acceptance letters, we can develop the accounting codes so we can track the different activities that go on. But what it means to all of us, I think, is that starting March 1st, we should have a viable pooled fund. Actually, NRRA Phase 2 ended in January of 2026. So we kind of got a 1 month gap in between. I would have liked to have seen this started January 1st, but looks like it'll be March 1st. We should get started. These are the commitments that we've received so far. It's on the pooled fund website. This is as of before TRB. I did not change these, so some states may have put some money in. We'll be talking to the executive team about this, about each state and where the money's at. You know, we're still waiting on a few of the states. They said they're in. It's just a matter of when they're able to put this money into the system. And again, Wisconsin, as you can see, puts money in every year. The tollway, we'll have to talk to them about doing a 2-year agreements for that, like we've done in the past. And you can also see Michigan has added extra money for working with sensors they're going to be installing, to getting some help with that for Michigan test sections. That's something that you're able to do any of the states. If you want to put extra money in, we can figure out ways to kind of work together on different projects. Like they're working on a concrete test section in Michigan and how to instrument it, and getting some help from MnDOT staff. Tom Burnham's working with them on that. So when it all comes down to it, when we start getting dollars in, and this is getting towards, well, how much money do we have to spend? There's SB&R dollars, I'm going to say dollars in hand, meaning what's shown on the website. So this is like one bird in the hand is worth 2 in the bush type of thing, where you're saying, we know we have so much dollars in hand, but we expect so many dollars. Like I said, Wisconsin puts in money every year. So you kind of assume that the money's there. And this is something I'm working on with MnDOT. In the past, we assume money is there, and money tends to come to be there to spend. So these two things here shows what we have in hand or what we expect, a reasonable expectation. So you can see how there's the NRRA activities. Some money was put in just for VEDA. It shows 1 state's put in, but we expect 2, the 150 to 300. 1 state put some extra money in for implementation. Travel, 1 state put more money in, but we expect more to do that. And then the other was the concrete stuff. But again, we're working this with the executive committee. So when you looked at what the executive committee initially set up, they set up certain percentages for each activity. So we had research contracts, labor, sensors, shipping and stuff at MnROAD, out-of-state travel, the construction we wanted for the low volume road, and then tech transfer. This was kind of the budget that was set up, the dollars. So if you take that again, you could have money that's in hand or it's projected or future. And you see there's a difference there. So what do you plan for? Do you plan for the 4.5 million or plan for the 6.7 million? So we're kind of working on that. We'll need to work on the percentages with the executive committee. We also have kind of the whole thing of, you know, how does this turn out for each team? What can we expect if we split the money evenly? And the executive committee needs to talk about this. But again, if you took the in hand or future, you're running between 600 or 575,000 each team to 891 or say 900,000. So I guess that's still kind of up in the air, how much money we have, how we plan for it. But again, this is why we don't fund things all at once, because money trickles in later on. We fund it later on. The other thing to keep track of is that NRRA Phase 2 had some carryover projects that MnDOT did not fund because we didn't have the funds in place at the time. So those will be brought over to Phase 3. So that's the concrete monitoring that we were planning on doing. Talking about the concrete support. Again, that's kind of separate for Phase 3. That's not really a carryover, but we've been talking about it. But there's also the flexible team has perpetual pavements. There's a spray rejuvenator, third year analysis. And then the Geo group was talking about over predicting resistance of non-displaced piles. So those are some projects that we'll fund now when we get the charge numbers starting up in March. But again, teams right now have been kind of working on ideas for research, but there's been no official call for research. That's to be determined possibly this summer, that we'll kind of get into. Once we have the money set up, the accounting ready, then we can start developing the research ideas for this summer. Related to construction, it's kind of the same thing. Right now, we've been trying to say that there's ways you can do construction through partnerships and things like that. And then there's kind of the full-blown contracts with a letting and everything else. That full-blown process takes more time, of course. So we've kind of always had the window open for opportunities for the low volume road. Again, the main line right now has construction traffic on it. We won't have access till next year in 2027. But again, if we do anything in 2026, it's most likely going to be partnerships, kind of smaller things. We don't expect a lot. We do kind of expect 2027 will be more of our efforts where we'll have money from NRRA to do work on the low volume road. We have some MnDOT money to work on the main line. And so we'll be probably gearing up more towards 2027 than 2026, but not saying that we can't do anything in 2026. So sorry if that's wishy-washy, but that's kind of, we'll have to see where it goes, where the test sections are at, and if we have any failures in the low volume road, which we'll need to fill in 2026. The flooded road is something that we will be working on. We are working on some instrumentation for that. We'll be trying to flood that this spring and collect some data. But again, that's not a funded project yet, but we'll be collecting data, assuming that it will be to look at the recovery of that flooded road and to feed that future study. Looking at the Pavement Conference, a couple slides and I'll be done. Again, the Shoreview Community Center, Minneapolis-St. Paul, will be doing that April 29th to the 30th, 2026. Don't look at the header there. It should be 2026 NRRA Pavement Conference. But again, we'll have a general session. Again, the Rohrbach Award, local area person went to John Garrity, from MnDOT here. And the Skoke Award, the national award, went to George Chang, Trans-Tech Terracon. We're having George talk in the conference in the general session, but it'll be led a lot with the teams and talking about their projects or what they're doing. There'll be some student poster opportunities. We need to get that information out to professors out there and the students out there, but opportunities for students to be there and be in front of their future peers and work with them. But we'll also have day 2, we'll be doing some morning updates in Shoreview. Then in the afternoon, going out to MnROAD and having an open house. That's a good opportunity there there's been some groups talking about doing demos for equipment and things like that, maybe some presentations out there and what they're doing. So again, more information will be coming out in the future about the Pavement Conference coming up. So with that, I had this slide at TRB. I don't know if anyone has seen it, but this is MnROAD and me ice fishing on one of the ponds. It's only 5 feet deep, so I didn't fish very long because I don't think there's anything there. But the rest of the agenda, Michael will be filling in for Kurt Dunn for the Flex team. Tom will be working with the Rigid, ICT with Kyle, PM with Tyler, and with Geo with Raul. Raul's gone, so I'll fill in for him. We'll probably do a little less Geo this time, so we'll leave some time, extra time for the Flex and the PM that I think they have a little more time needs for this quarterly meeting. So is there any quick questions for me before I give it off to Michael Vrtis? Let's see, there's a chat here. All righty. Thank you. I'll lead that off to Michael now. Can't hear you, Michael.
Try that again.
There you go.
Good
That's
morning,
better.
everyone. And can you see my slides?
Yes.
All right. Good. Yeah. Thanks, Ben. Nice to see everyone, at least online. Just scrolling through the names. Good to see some names and people we haven't heard from in a while. Quick agenda today from the flexible team. Kurt Dunn is on vacation today, so I'll be filling in. And as Kurt and I were talking about this meeting last week, we really decided to do a conference preview or teaser. Specifically, I'll get into some of the recent MnROAD reflective cracking challenge results. And then I will be joined by Dr. Meisam Khorshidi from the University of New Hampshire, presenting on some of the modeling efforts that really go along nicely with the reflective cracking performance that we're seeing here at MnROAD, especially related to our cold temperatures that we've seen in January. So for the NRRA conference, we are going to be combining with the PM team and sharing some time. We're really excited about the speakers we have lined up. We have some really high quality and polished national speakers on exciting topics. These kind of how Kurt and I like to approach this, or the flexible team in general, is what are we working on? What's happening in asphalt that we want to share with the wider audience of basically a pavement engineering audience, not particularly asphalt experts. So what do we want our other pavement friends to know that Flex Team and Asphalt is doing? So we have Dr. Bill Butler from University of Missouri on the companion sections to the sections I'll be talking about today. And then we have Dr. Ishan Dave of New Hampshire talking some balanced mix design. And then kind of looking towards the future, we have Dave Johnson from the Asphalt Institute talking about the Utah High Mod sections, or Utah High Mod mix. It is something that both the Flex team and the PM team have rated highly for future construction ideas. So it is something that we will probably look at through the NRRA lens. But Dave will kind of give an introduction to that. And really, it's a highly polymer modified asphalt placed at extremely low air voids. And then day two really is the teaser I'll be giving today. And that is I'll do a more thorough performance update from the MnROAD sections. And then Ishan will provide some of the lab testing correlations that go along with that. All right, now shifting gears to MnROAD. For those of you who didn't know, January was very cold here in Minnesota. We didn't get the snow or crazy weather that a lot of the rest of the country did, but we were very cold. So it was the lowest temperatures we've seen in 5 years. Beginning of the month, we had 5 test sections without cracking. By the end of the month, we only had 2 test sections without cracking. All the cracks that we've observed in the test sections are reflective over saw cuts. So we do not have any naturally occurring thermal cracks or any type of other distress in the sections. There's 7 saw cuts in each section, a total of 175 feet possible of reflective crack length. And then all of these surveys and pictures that I will be talking about is done visually from the shoulder. So we weren't actually able to get out and measure under live traffic. So not quite the level of detail, but still pretty accurate, as you'll see in the slides and pictures I'll be sharing. So just a reminder, we took our conventional 400, 500 foot test section and we literally saw cut it in half in the lower lifts. So the 2 lower lifts total 4 inches thick, and there is a transverse saw cut at fixed locations, 7 cuts in each cell, same spacing in each cell, really providing the same platform 10 times so we could evaluate 10 different overlay mixtures. So I'll be focusing today on some of the control sections where we're changing the binder grade. And then additionally, I added section 2234 just to talk about some of the ones that have intermediate performance that's falling in between our control setups. All right, so looking at our winter here in Minnesota, so I've got Fahrenheit on the primary axis and then Celsius on the secondary axis. I like to include Celsius with these because it gives a nice comparison to the PG grade. And you can see that in December we had a pretty cold day, but it warmed right back up pretty quick. Whereas in January, and I'll show more on the following slides, we really had an extended period sub-zero or held at cold temperatures. So a closer look at January. Again, we got down to minus 30 Celsius or minus 21 or almost 22 Fahrenheit. It was January 23rd was our coldest time. Kind of funny that the same period over Martin Luther King last year, same Martin Luther King weekend, a year later we had our coldest temperatures again. And then we did have a total of 66 hours consecutively below zero. So our high temperatures were also below zero. This kind of sheds light into some of the asphalt cracking theories on whether or not cracks occur when we reach a maximum low temperature, whether it's a duration of extended period of time at cold temperatures, or if it's how fast we get to a cold temperature. I'm showing all air temperatures here. We also have thermocouples within the pavement. So we are actually measuring the temperatures within their asphalt themselves. So that can be further dug into as we go to make correlations with crack performance and timing and temperature. Survey dates, we really were closely monitoring our reflective cracking and naturally occurring thermal cracks, which we did not see at all over the month of January. So as we were going through this cold stretch, we were looking at it almost every 24 hours, seeing what cracks were new, and then when reflective cracking did occur. So summary, kind of picking the earlier in the month before we had cracks, middle of the month, and then, or beginning of the cold stretch and then end of the cold stretch. Remember, it was the 23rd that was our coldest temperature that we had. So focusing on these 4 cells, 2234, which is a polymer modified 58, or 2239, a polymer modified 58H minus 34, held pretty steady throughout, where we came into the month with 2 out of the 7 cracks, 5 feet total, so very minor cracking, still visible. And then it ended with 6 feet total. The 49 minus 34, there still has no cracks in any of the saw cut locations or anywhere in the section. Going to the other binder, the 58S minus 28, it was cracked going into the January, and then a little bit of increase in the crack distance, but still pretty heavily cracked, reflective cracking throughout. And then I added cell 2234 to this presentation. It started the month with no cracks, and then by the 21st, we had 3 out of the 7 had cracks, only 8 feet, so still just a couple feet in each of those saw cut locations. And then at the close of the month, we had 4 locations cracked with a total of 17 feet. Big thank you to Jacob Calvert at MnROAD for helping me with all of this distress survey and braving the cold temperatures to get this data. So what we do, we like to take the same picture over time so we can watch the crack progression, progression. So this is the 58H minus 34 section. You can see on the 21st, it's a couple feet just extending into the outside wheel path of the driving lane. On the 23rd, that crack has grown. And then by the 29th, it's all the way across the driving lane. The 49 minus 34 section, no cracks in the section at all. These orange marks that you see here on the shoulder, that is the GPS located location of the saw cuts underneath. So those are the areas we're really closely monitoring because that's where we expect the reflective cracking to occur. Section 2230, this one did have crack. All 7 of the saw cuts had reflective cracking going in. We're still monitoring that as we're seeing the width expand and then deterioration along the wheel pass as well with these sections. And then the one that's in between, 2234, beginning of the month, no cracks. The 21st, still no cracks. And then by the 29th, there is a crack in here. I zoom in here and you can see it, especially if you follow through the edge stripe. So here's our orange mark, and then it is right in here through the edge stripe. All right, at this point, I am going to turn it over to Meisam to kind of share the modeling updates from the New Hampshire side of things.
All right, thank you, Michael. I want to walk you through our report to predict the performance of mercy test section using 4 mechanistic and mechanistic empirical models, including pavement exocycle, flex wave, and LETC. For these models, the pavement structure, underlying condition, traffic, and climate inputs were kept constant across all the sections, and the only input that varied was the material properties, as Michael mentioned, measured in the earlier project tasks. We also explain how mixtures was ranked based on the output metrics from each model and how we compare those ranking with the cracking performance that you just saw. Next slide, please. So here, yeah. So here I just talk about mostly on the materials we have used for each model that we have had. We mostly use dynamic modulus and also the thermal contraction and expansion properties for all models. But at the same time, we use some specific properties like fracture properties extracted from overlay tester and also fatigue result to run the analysis in the models. Next slide, please. So as I mentioned, after putting those input inside of the models, we got some output from that. For example, I'm going to start here with the Texas cycle outputs. You see the reflective cracking rate we got from it. That is over time, and you see the curve shape we have here. So we had these kind of output, and we tried, because of the sake of ranking, we try to convert these curve shape to kind of a single metric like RC total that I'll show you in the next slide. Yeah, so we could get RC total based on the service life we had and the area under the curve as you see in the equation here. So we could get a single value for each test section, and then we converted those to a kind of a ranking base for each model, especially here for Texas cycle. Next slide, please. For flex wave, we could get percentage damage as an output for total top and bottom damage. And for the sake of ranking, we use the top damage to rank and compare the mixtures compare the mixtures output from this specific model or tool. Next one, please. And also can you go here? And also for EDTC outputs, we got 3 different outputs from the EDTC, but we use the number of critical events because we could get more distinction between the mixtures and whether to say test sections here. So we will be able to take a look at the number of critical events, but as you see, the annotations show the predicted cracking amount. On the top of each bar show the predicted cracking amount and the percentage of thickness that have cracked through the pavement, through the overlay layer. Next slide, please. And finally, same as Texas Accord, we looked at the output from Pavement ME tool, and we got the same output reflective cracking rate. And so the same concept as Texas Accord, we try to convert it to the RC total that you see in the next slide as a kind of a method to be able to rank the mixtures and test sections. Next slide, and next slide, please, again. Next slide, please.
Okay.
Yeah. So we had some circular red points here. Yeah. So thank you. We try to here that I'm going to summarize what we got from each model and how we rank those. We try to look at the output from different models and compare those with the FPR, field performance ranking, I mean. You see the numbers in each column that shows the ranking for FPR, and at the same time for the models, and the numbers in parentheses shows the differences between each model ranking and the FPR we got. As you see, and as Michael talked about it, we got 58S minus 28 control as our worst performer in the field. And we had some good performer like S49 minus 34 when we look at and observe the field performance. And then moving to the Pavement ME ranking, we figured out Pavement ME couldn't exactly find the best performer, and couldn't find the worst performer because 49 minus 34 was the worst performer for Pavement ME, which wasn't the worst performer based on the field performance ranking, and it didn't have any kind of crack there. So Pavement ME couldn't detect the worst performer, but it could find some of other test sections we had as best performer, and in the middle level performers, it could does a good job for us. Moving to Texas Accord, it could get the worst performer. It couldn't get the worst performer, and it again detected 49 minus 34 as our worst, but it could get 58 as minus 28, our worst performer in the field, closer to the end of the distribution and closer to the 10 number. I forgot to say that the 1 here means the best performing test section, and 10 means the worst one. Moving to FlexPave and LTC, these two models could figure out what is our worst performer. That was totally match and align with field performance ranking that we had. And at the same time, LTC could find some of our best performer, for example, 49 minus 34. So this was a kind of a summary we had from the mechanistic and mechanistic empirical models we applied to our lab test result, that a kind of an input that we got from our earliest project task. And if anyone has a question.
Let's chat there. 2 questions.
There are 2 questions there.
So I'll handle the questions regarding which binder grades and that stuff that was used. I deliberately did not include those just because this is a marathon and not a race. And I want to just caution jumping to early conclusions based off the preliminary results. We do have everything listed in the published project reports after they're reviewed by the TAP. Those are all posted online. But just the preliminary data, and don't want people jumping to early conclusions. Really, as a MnDOT agency, we really only care what cracks we see during this winter. It doesn't matter to our maintenance folks if they see it in January, February, or March. It's what do they need to fix and get ready for next year. It's really the research level that is going to be benefiting from this fine-tuned cracking analysis. And Meisam, I'll read Bernard's question for you. Yeah, Ishan.
No, I was just going to say the same thing you said, that we'll read the questions from Bernard and Tyler, but go ahead. Yeah.
Yeah. So Dr. Bernard is Webekai. Your equation that had the square of the service life as denominator looks very interesting. Is that your novel idea or is it widely accepted algorithm?
So I'll respond, and it's actually you can thank Dr. Shangtao Dai for the square in that equation, because that equation originated from a previous MnDOT work that we did, and the idea is that so that the final outcome of that quantity still comes out in a meaningful unit in terms of % of reflective cracking per year. And in order to do that, you have to square the timeline. Since the way we calculate RC total, we are looking at the combination of rate and the time. So time gets squared in calculating. So by normalizing it with the square of time, it just gives us a unit that for engineers is a little bit more meaningful, that the outcome looks as what % of cracks are reflecting through per year as a unit, while giving credit to overlays that crack later in time versus earlier in time. And that's the whole idea there. The second question, Michael, go ahead. And I don't know if you want to answer that. So, yeah.
Yes, that's an easy one. I can take that one. So from Tyler, so far, does the 49 minus 34 appear to resist cold weather reflective cracking better than the stiffer 58 as expected? Yes, it does. We're clearly seeing that the 58 has those big wide cracks in it. And then where the 49 does not have any cracking, I should add that there is more rutting in that section than the other sections. It's still, I think it's about 1/4 of an inch, so well below kind of our 1/2 inch threshold, but it is starting to separate itself from the other sections as far as rutting. And even in the pictures, you can kind of see more binder loss or deterioration in the wheel pass of those sections. I'll jump to it real quick.
Yeah,
There's
thanks, Michael. That was going to be my follow-up question, was the rutting, so you already hit on that, so thanks.
Yeah, and you did make a really good point in there that I don't think I emphasized, but I do think is a cool takeaway from this, is all of this reflective cracking that we're seeing occurred at the low temperatures. So it is a combination of traffic and temperature. We are seeing more cracks in the driving lane with the heavy vehicles than we are in the passing lane as well. Any other questions? All right, really want to thank Meisam again for presenting for us, and thanks everyone for their time.
All right, thank you. Thanks a lot, guys. Tom, you ready to present for the rigid team?
Sure.
Let's see. I can see your presentation.
Mm-hmm. Is it in a good mode?
Good enough. Go ahead.
Okay. Thanks. Well, good morning, everyone. Thanks for the opportunity for the rigid team to give you an update. Don't really have the same kind of update for planning for the conference. We have a couple of speakers lined up, still working on another one. But just want to kind of review where we're at in our team as far as current projects. 4 of them are involved with the low carbon concrete test sections we built in 2022 and 2024. The 3 of those are kind of wrapping up with their year 3 performance reports. And again, you saw Ben noted the fact that we're going to be extending with another contract to continue to monitor the performance, since some of you don't see anything, some of you are starting to see a little bit going on, but we feel that we need more time to really assess how those things are going to perform in our climate. We also have a project on the use of polymeric microspheres in replacement of liquid air entraining agents. And so that project's moving along well. Then we have a couple of internal projects here that me and my colleague Mike Wallace are working on with early loading to increase joint deployment and concrete overlays, and also looking at repairs and diamond grinding of concrete overlays. And I'll be giving you an update on some of the findings right after this list is done here. We did install some rapid strength cement concrete mixture in the low volume road a couple panels back in 2024. So that project is moving forward. I'm watching how that performs. And then we have a couple of co-sponsored projects, one with automated 3D GPR analysis for concrete pavement evaluation. So that one's moving along well. And then another one that's probably wrapping up is continuing monitoring of the asphalt overlay sections on old concrete, given the fact that those sections are now gone. So we have 3 lanes going through next to our project now. Any information you want on those projects, updates, you can always look on our active project website. I did want to mention another probably interesting study that MnDOT's involved right now that maybe you're interested in too, as well as we have a study called Our Current Rigid Pavement Design Roundabout Designs Working Minnesota. So that project is moving along. The team went out and visited a whole bunch of roundabouts throughout Minnesota and kind of trying to assess, how are they doing? What are we doing right? What are we doing wrong? So keep an eye out for that one. Projects in development, Ben mentioned that we have several of those again lined up for contracting to continue monitoring the performance of those low carbon concrete test sections. And then we're starting to charge ahead a little bit to plan for some sections on the low volume road and also the stockpile area. And some of those ideas involved placing some materials that have been used at the UC Davis Lab to Slab project, and also some sections that University of Pittsburgh has been studying, and with the idea of similar to MnROAD asphalt and NCAT track, this would be kind of a concrete version of that, where we have sections built in different climates with the same materials. We also have interest by the team in understanding the opportunity of maybe reducing our dowel bar diameters. So we put together a test section where we will have various configurations of dowel bars and size and both that and spacing. And then something called the pavement buckling test pit that I hope that we can explore, and that would be put in the stockpile area where we would try various surfaces as well as materials underneath and try to understand what the mechanisms are that cause this pavement buckling that we continue to see when we get those very long hot stretches during the summertime. So we're hoping to perhaps maybe we can kind of tackle that this year because it's a little bit more affordable than some of the full-scale sections. So I'm going to devote the rest of my time to giving you an update on this project of the performance of diamond-grown concrete overlays on asphalt. And that's being done again by me and my colleague Mike Wallace. So a little bit, I'll give you some background, the objectives, and then talk about some performance results from the 4th year of the Woodbury project and the 2nd year of the I-35 North Branch project. So just so we're clear about what we're talking about, concrete overlays on asphalt, often in the past called white topping, concrete overlay on an old asphalt layer, typically milled, not always, but typically milled to improve the bonding, and then just whatever's underneath as far as base and subgrade. Some of the features of these thin concrete overlays is that the panels are pretty light. When you start to look at the weight of the actual panel, in this case a 5-inch with the 6x6 panel, which is very typical, it weighs 2,250 pounds. Now you compare that with your axle weight, which you look at 9,000 or more. These things can get pushed around quite a bit. It's not like a big, huge, heavy slab that we have on normal pavement. And again, for concrete overlays and asphalt, the panels are bonded when they begin. What we notice is that over time, at least in the Minnesota climate, is that we start to lose that bond. Water gets in the joints, starts working at the bond, and once you lose that bond, then again, you have just a very thin pavement laying on top of an asphalt layer. And really, the idea is that you'd like to take advantage of that bond and reduce the stresses in the concrete surface. Now, in wet, freeze-thaw climates like Minnesota, we have seen pretty regular trend that the transverse joints start to fault, typically within the first 5 years of service, which is not not something you want to happen. And in fact, this has been recognized, and back in 2021, NRRA completed a project that added a faulting model to the BCOA-ME design procedure. So it's recognized that this happens, and it's one of the distress mechanisms that we have to deal with for these kind of concrete overlays. So the study objectives here, this is part of a larger study, but I'm going to focus here on determining the efficacy and the longevity of diamond grinding as a mitigation method. So if we have faulting in these concrete overlays and you go out and diamond grind it, how much longer life do you get? And again, this particular study involved a section in a suburb here, Woodbury, Minnesota. Also 4 MnROAD test sections, and then another section on up on I-35 Interstate North Branch, Minnesota. Excuse me. I'm only going to cover the ones in blue there, the Valley Creek and the North Branch. The MnROAD cells, that analysis is kind of done since those cells have been removed. I could kind of say that because of the extreme interstate loading and the condition of those sections, they didn't perform very well, but we can kind of compare that with what we see with maybe a more normal project. So performance update, again, we're on our fourth year of monitoring the Valley Creek Road project, and then on the second year of the I-35. And the type of results I'm going to report on is distress information, just general condition, fault meter measurements, joint performance based on FWD testing, and then ride quality measurements. So Valley Creek Road is a 5-inch thick concrete overlay on 4 inches of remaining asphalt. At the time it was milled, it was 42 years old, so something to think about when we're talking about these concrete overlays, that the asphalt underneath is not in its prime of life. So something to consider. Again, 6x6 panels, which is very standard design. This happens to be a suburban collector route, so kind of not a lot of heavy trucks, but just a lot of general traffic and quite heavy during rush hours. It was constructed in 2012, and by the time it started developing pretty noticeable faulting, and then the Washington County decided to diamond grind it in 2021 to kind of see how it was going to do. And at the time, the condition of the concrete overlay itself was pretty good. There was very minimally cracked panels. So again, they're just going to go out and diamond grind it. You can see the pre-grind average faulting meter readings range anywhere from 1 to 4.5 millimeters with an average of 2.2. And it doesn't sound like much, but when you get over 2, you can really noticeably feel and hear, the clunking of the tires over those joints. So this is a photo taken just last fall, October 2025. At this point, the overlay is 13 years old. Again, it's still in pretty good condition, starting to get some cracked panels that are starting to increase in numbers. And so here you can see kind of comparison a year by year back in 2024 versus 2025. The cracking is starting to deteriorate over time. And we're right now up to 22% of those test panels have cracks. That was up from 13% the previous year. Again, some more photographs of the cracking. You can kind of see they're starting to deteriorate, the existing ones, but you can see there's several panels too that are not cracked at this point. We did notice near the end of the section there's kind of a opening of the mid-lane joint, and to the point where it's almost as wide as a quarter. So this is, sometimes we see this, especially with ones that have not used tie bars across these joints. So again, they kind of drift with time, and it probably is also an indication that you've lost your bond with your asphalt, so it's kind of drifting to the side. This graph here is pretty messy, but it's kind of showing you the faulting levels, anywhere from post-grind, which should be, again, down near between 1 and -1. A lot of variability because when you're diamond grinding, you leave kind of fins that, again, get broken down over time, so that some of that variation, especially the negative numbers, go away. But what you can see is that we're back up. If you look at the one, follow the line, we're back up over 3, 4, we're pretty much kind of back to where we were, where we started. Similar to this, so this just focuses on pre-grind versus where we're at now. So again, you can see that the data is really falling back to where it was when we started before grinding. And that's reflected in this historical graph too here. So pre-grind average about 2.2, dropped way down when we ground it. Within 2 years, we were pretty much back. It's not changing much, and you can start to see the whisker plots there showing that there's quite a few more joints now, getting much more faulting, and again, it's starting to look like where it started. So ultimately, you can kind of say they maybe got about 3 or 4 years, and they're kind of back to where they're at in this particular project. Kind of unfortunate. FWD testing. This is some of the nomenclature. We typically test before the joint and after the joint. So this is kind of what it looks like here. Again, just showing the joint performance post grind, and then 4th year. Again, we're very little change. Same with this. Again, low transfer efficiency. You can see they're not very high. I mean, we should not expect too much difference here since we really didn't do anything to the joints. We didn't do anything underneath to solve the issue, which kind of caused the faulting anyway, which is the lack of support. So again, we don't expect big changes, although I went back and looked at the data and noticed that actually the low transfer efficiency kind of dropped after the 1st year, but then it came back. So some of it's seasonal variability, but we always try to test in October, and we've had pretty good luck with pretty consistent climate conditions when we do this testing. Just for an idea for some of the deflections, this is in microns. Again, we're really very little change over the years. And then this kind of shows the ride quality history. So you can see we started pre-grind, IRI numbers as high as 150, dropped way down to 50 or in the 40s post-grind, and then within about 2 years back to 96. Now we're back up to 130. So even though the faulting is fully returned, the ride is still not as bad as it was before it was ground. So it's kind of interesting that it's lagging a little bit despite the faulting. So a summary of that, the overall distress level, I would say, is low. The crack panels continue to form and deteriorate. The lane separation appears to be stabilizing. The 4th year fault meter readings are very close to pre-grind levels, and the rate of the faulting redevelopment appears to be slowing. The ride quality is declining, and it's starting to approach the pre-grind level. So the county has asked us to test it one more time, so we'll be going out there in October again, and that'll probably be the last time we'll be monitoring it. Moving on to the I-35 project. This is an I-35 interstate north of North Branch. It's about 30, 40 miles north of where we're at here. 6-inch concrete overlay on 4 inches of minimum asphalt, 6x6 panels. Construction in 2009. At the time, there was some panel replacements, and then there was a diamond grind done. We focused we selected a test section that only had diamond grinding, no repairs. Traffic is kind of a rural interstate, I would say. It's not real heavy truck traffic route, but it is an interstate. And you can see the pre-grind fault meter readings went anywhere from 1 to 3.6 with an average of 1.7. So not quite as bad as the Woodbury project.
Hey, Tom.
Yes.
Quick, speed it up a little bit, if you would.
I'm almost done. Yep.
Okay.
No problem.
Thanks.
Yep. Typical condition, again, not too much cracking. Any cracking that happened pretty early. It was some transverse cracking, but nevertheless, pretty good condition. And then this just shows we have two test sections, northbound and southbound. And you can see that pre-grind, we're up about 1.7. It dropped way down, and then it jumped a little bit the 1st year, and now it's kind of stabilizing. So it's not at the same rapid rate of return as the Woodbury project. And that was for both directions. So I'll skip these. sake of time, we move on to the ride quality here. Again, the pre-grind up about 100, we drop down to 40, and it's slowly coming back. So again, this particular site is doing better again, but we're only at 2 to 3 years after grinding. So summary, overall distress is still very low. Faulting, very small increase in year 2. And now we're starting to see the ride quality index again creep back. But again, it's much lower rate than redevelopment compared to Woodbury section. We're going to continue to monitor these projects, one more year for Valley Creek and 2 to 3 more for the I-35. And then we have a draft report coming up to the TAP coming in March. And we're probably going to likely extend this so we can continue to monitor these sections, especially the I-35 project. With that, I'll take any questions. Thank you.
Why don't we, for the sake of time, if we could do the questions to the chat, that might be best.
Sure.
So we have the ICT, PM, and the Geo group to follow till 12 o'clock our ending time. The Geo group will be very short, but Kyle and PM team, we gotta get going. So with that, Kyle, do you want to go from here for the ICT team?
Sure. Can you hear me all right?
Can hear you.
All
Can
right.
see you too.
Awesome.
You might on presentation mode.
Okay, there we go.
There you go.
It was I saw the spinning wheel of death for a second there, but it looks like we're in good shape. Yeah, so thanks for the opportunity to give an update. We have a few things to cover since last time we met as a larger group. One of those being that the ISIC 2026 conference is there's a location, and this is the conference that was held down in Florida last time. This is going to be in Louisville, Kentucky, and the theme is collaborating through technology for value engineering. We also had a nice TRB workshop on density profiling system, and we should actually have some documentation from that conference as well. I know in the past sometimes there's e-circulars and things like that, and I know through the pooled fund, DPS Pooled Fund will put together some meeting notes on that. So, and then of course George and Rebecca did a great job on the research pays off for this group. We do have kind of a skeleton of what we want to cover for the more technical portion of the workshop. Spare the speaker details and all that, but the main point here is an overview of ICT technologies, and then trying to make sure we're getting all the different stakeholder perspectives on the various aspects, because there can be some gaps in communication between those various stakeholders, and we want to make sure that all the incentive structure is set up to be able to implement these technologies and get use out of them. And then the second day will be an update on our current projects, and I think last time we met as a group, Sahil did a good job of updating on both of our projects, so we'll save that for next time. And then we're also co-sponsoring the 3D GPR study that Tom mentioned. So for today, I wanted to give an update on our, we have a couple of MnDOT pooled funds that are related to intelligent construction technologies, one of them being the continuous bituminous pavement stripping assessment through NDE technologies that EOB is running. And then we also have the continuous asphalt mixture compaction assessment using DPS, and that's the one phase 2 of that project that I just wanted to briefly update this group. There's just been some developments that I think might be of interest to this larger group. So and it covered a larger portion of this in a December TRB webinar that was well attended. So just took a few slides from that presentation to make sure you guys are all up to speed on what's going on there. So the objective is the same as the first phase, still trying to improve asphalt density through implementation of DPS technology. However, the 17 states and federal highway, we have kind of less of a research focus and more of a implementation focus for our work plan for this pooled fund that just kicked off last July. And a big portion of this is on pilot projects and trying to get trial implementations and get the technology out there for people to use. So that obviously is going to require having a robust software, and some of the main reasons for that is, you know, as you can see in the upper left there, a need to integrate it with all the other intelligent construction technologies, and then also be able to handle when new technologies come around. So one of those being 3D radar that became available the previous construction season that we've presented before, but then also new vendors come and new forms of data collection, which we'll cover here quickly today. So the biggest development here is being able to mount the DPS on the roller compactor, which has been a concept for a long time now. And we've actually been able to get it on 3 different projects in Minnesota this past construction season. And I guess the biggest advantage, at least from my perspective here, is the safety and ability to get the data that we've been able to show is really useful, but do it without having an extra person exposed to traffic. So in this case, it's just mounted to the bottom. It's part of the paving train. We used it on the final roller compactor because we're more interested in quality management, quality assurance type activities, but it can also be put on a breakdown roller and other rollers for more quality control type activities. But what you see in the video there is actually a live percent GMM coming in on this finished roller, and it's just getting mapped on that software as they're going along. So like I said, we have a lot of comfort with our cart-based collection that we do after the final roller, and we were able to do a lot of qualitative assessments and are starting to do some geospatial quantitative assessments to ensure that these trends of finding the lower and higher density mapped on the pavement can get picked up by having a sensor on the roller. And like I said, so far we've seen really good agreement between kind of our existing technology and this new roller mounted option. And just briefly, you know, one initial way that we can use this type of technology that's kind of lower risk than giving an absolute density assessment is just a variability type measure. And the advantage of this is that this technology is based on measuring dielectric constant, and changes in dielectric constant correspond to changes in air void content in each specific mix. So in this case, because we know the dielectric constant of air is always 1, our variation in density is a really robust measure, regardless of what mix you're on. And some of the complications with calibrating to each specific mix are no longer as much of a barrier to implementation with this. So this is just kind of an example of being able to look at variability within limit throughout 150-foot sublots on a project. And then before I end, also reminding people that, you know, just because the states are looking at it as a quality management or quality assurance tool, it's also a good tool for quality control, especially if we can get it on the breakdown roller. So this is just an example where there's cold mix near the gearbox in the paver, corresponding to lower density as measured by the DPS. There's also a lot of examples with comparisons with IC, this one showing less roller passes near the joint with the breakdown roller corresponding to lower density at the joint. And sometimes the fix is simple, you know, where it's just in this case with the echelon paving with the breakdown roller swerving around the outside of the adjacent paver, that was what was causing the lower density. So hopefully with the implementation of all these ICT technologies and specifically DPS, we can start to see less of this type of paving on our roads and get longer lasting pavement. So with that, we'll maybe take questions now or later, depending on what Ben wants to do.
Why don't we try to do them in the chat, Kyle? Nicely done. Thank you for that.
Yep.
With that, let's go to the PM team. Tyler?
I'm actually going to turn it over to Adriana to make sure she has enough time, Ben, and then I'll get to my presentation.
Okay.
Kind of quickly to go, if that works.
That would work. I probably need 5
Okay.
minutes at the end.
Okay. So if Adriana, if you're ready to go.
Oh, yeah.
Perfect. Thank you.
Let me see. Make sure I'm sharing the right window. All right, can you see that?
Looks good.
Okay, and I'll be brief because I figured we had a lot of information here, so I'm only touching up on some of the highlights of the project. But what we are doing here is for the use of recycled materials in pavement preservation, trying to establish a framework for evaluating the feasibility of different options for recycled materials. But after we conducted our lit review and just a survey of the NRRA states, we went for the low-hanging fruit here first and looked at 100% wrap designs, and that is including microsurfacing, chip seals, and slurry seals. So a lot of our effort was trying to obtain materials, because the purpose was if we're getting aggregate from a given state, we want the emulsion that goes with that aggregate. So trying to obtain all of those appropriate materials was a very big part of the effort. We ended up with type 2 microsurfacing from Ohio, and that is both the virgin aggregate and the wrap. So all of those are coming from the same area. We did have some materials from New Mexico for chip seals as well. We've been working on a project with them and thought to leverage some of that. And for our slurry seal, we have materials from New Jersey. Again, same thing. The wrap and the virgin aggregate and the emulsion are all coming from the same source. And just to give a little bit of an idea of what we have seen with our results in our projects, and looking at the microsurfacing results, for example, we did see that the wrap helped enhancing the raveling resistance. We can see with the wet track abrasion test, and you can see here this orange points would be for the virgin aggregate. The line here is the maximum loss as defined in the AASHTO R103, 102, the one that's for microsurfacing. So you can see if we go 12% emulsion content, we don't meet that. This is for the 6-day soak. Specifically, we saw more of a deviation and a difference between wrap and virgin aggregate. The wrap, either 12 or 11%, it didn't seem to vary that much, and we were well below that loss. So we can see there that right off the bat, we could see a reduction on the required percent emulsion if we're using wrap. And I think that makes sense because it may be less absorption that you get there. Not so much that there's a contribution from the binder, but I think it could be attributed more to the absorption than anything else. We also saw improved cohesion with the wrap materials, and you can see there 2 samples, 1 wrap, 1 virgin aggregate. This is at 30 minutes. Both of them are meeting the requirement of 12 kilograms per centimeter, but the mode of rupture is different. You can see here the wrap is what they call it, a near spin, just a single crack. With the wrap, oh, I'm sorry, with the virgin aggregate, we see more cracking around. So it is important to note that although both of them are meeting the requirement, the modes are different. We experimented a little bit with the running the loaded wheel test at higher temperature. And we do see something that was reported by the contractor that supplied the materials, is that with the 100% wrap mixes at higher temperatures, you could see more deformation. So you build it, you then go through a pretty hot summer, and you can see more just displacement of the mix. And this is for the same emulsion content, but something to keep in mind. We'll look more into this. We also did a little bit of testing with cracking resistance, and we didn't really see much of a difference between both of them. Of course, they have different contents of emulsion, but at the optimum, not a significant change in cracking resistance. And this test is pretty simple, and it's just a way to compare between two mixes. There's not really a number that you have to meet. And then moving on to the chip seals, we had a couple of wrap sources that we gathered from New Mexico, and one as is, and the way they are using it right now, the gradation bands do not quite meet what is in the standard, in the ASHTO standard. But I could say this one is more like a type A, the one from District 6, the District 1 is closer to the type B. So this is closer to like a 1/2 inch, and this is more like a 3/8. If we wanted to be more within what is specified in ASHTO, we would need to do some additional processing just to make sure that we're within those gradation bands. But we did all the characterization, went through the exercise of doing the design, and definitely, yeah, not all wrap is created equal. And the way that this compares to the virgin aggregate, again, we have to look at the different sources. In general, it could be a little less requirement for your emulsion, but we had several virgin sources, and there's a wide range also of differences in there. But we, just looking at this, it seems reasonable numbers as far as requirements for emulsion. So we continue here with the design evaluation. We want to do a little bit more testing, just with the polishing and looking at differences in what we will say performance. So things that are not part of the design, but that maybe we're looking into as we evaluate different materials that are not taken into account when the design methodology was developed. One thing that we're considering is doing specifically for the slurries and micros a 50% wrap blend, given those potential issues with the deformation. And this is what the contractor has been doing. They do use the wrap net at 100%. Our main challenges has been that since we're trying to use those materials that match, getting the emulsion supply, a steady supply, and especially now that it's not in construction season, has been challenging. But we're trying to catch up with our work and continue to move on with that. So that is my quick update for now. Thank you very much, Adriana. I think we're doing questions in the chat, Ben, so I can move on. And I'll give you, I got about 11 or 9 minutes. So
Thank you.
Yeah. Here, let me share my screen and I will get started. Everybody see that?
We can.
Okay, cool. Just want to give a quick update before we start with Dr. Yu's presentation that I'm going to give. He is traveling currently, so I'm going to try my best.
we have PM sessions sort of figured out for the conference coming up. I say sort of because we're doing a lot of team up work with the Flex team. I talked with Michael, and they have quite a bit of content to cover. So if you add up all 4 of these sessions, it actually equals 150 minutes. So we're kind of giving and taking a bit. This is our setup for day 1 currently. If Adriana or Zamping have stuff they want to update, though, I might ask for a little bit of time, either day 1 or day 2 on the reflective cracking challenge update. So, or I will give it as part of my 5-minute PM update. So that's what the conference looks like for PM right now, and hopefully more to come very soon on that if there's any changes. We currently have 2 of our 2023 funded projects in the works right now. The materials-based rumble strip durability study with the Flex team has been fully completed ahead of schedule. So we have the project that Adriana just gave us an update on, and then the hot rubber seal coat project as well. With that, I'm going to jump into Dr. Yu's presentation. He's on, so you can direct your questions towards him. And then, like I said, I'm going to do my best. So the main objectives of this project was to demonstrate the use of hot rubber seal coating to reduce premature stripping and extend the surface life of the pavement. Lab and field testing were both performed and to understand the advantages of using it. And it was compared with traditional chip seal emulsion applied chip seal. There's 8 research tasks. We're sort of in the task 3/task 4 arena right now, where we're doing laboratory testing and then field construction and field testing. There will be a draft final report, and actually this project is coming up somewhat soon. I want to say July. Zamping, if I'm wrong, you can correct me in the chat. So we're going to be rolling pretty quick here once things get finalized with all the rest of the testing. As part of task 3, they did do raw material collection of both the emulsion and then the hot rubber seal coat on site to test the products. And there was also laboratory testing conducted. So part of that was the oven dry to find the average mass loss to determine the binder content of the coated aggregate. So there was testing to verify that as we went along, and there was a coated aggregate test section. Another part of task 3, the laboratory testing, was bond strength testing in tension and in shear. The method was a epoxy glue was applied to the pavement, and we pulled it off in tension, and then the same thing with shear strength. So the results indicated for the tensile bond strength, hot rubber seal coat did show higher bond strength. It looks like across the board. And you can see the curves, the displacement force curves there. So that was positive results. The hot rubber seal coat also showed increased shear bond strength, especially in the no freeze thaw regime after the freeze thaw cycles. So it maintained good bond strength throughout, and it appears that you can achieve a superior bond strength than the traditional chip seal emulsion. We did construct a project back in July of 2024 with our Bay County Road Commission on M25, which is a MnDOT route. There was quite a bit of testing done with the hot applied chip seal with coated aggregates. So all of westbound was all the hot applied chip seal, and we had a small test section that included fog seal, and then eastbound was the same, but then there was an emulsified asphalt and uncoated ag with fog seal control section as well. That project went pretty well. It looks good to this day. I have Matt, my counterpart, out kind of keeping an eye on that project. We were a little concerned with just being a first of its kind on our route, but things have worked out pretty well so far, I should say. I'm sorry, Dr. Yu, if there's a video here, I'm not sure if it's gonna play or not. I'm gonna probably skip through though, in the interest of time. The pull-off testing done as part of field evaluation indicated that it was similar in strength with the with and without fog seal. So the average of 230 psi and then 243 psi in the pull-off tests. And then in comparison with the control section with emulsion, the pull-off test was 345 psi and then 332 for the traditional chip seal. So I would say pretty similar results in that area. We are also getting skid friction testing. The pendulum was used, the British pendulum was used on site, and this was done actually a year later. And the results were pretty similar to the traditional chip seal. So we're pretty confident in the friction. I am having our friction unit collect in-house data, but unfortunately it is pretty restrictive on me being able to share that outside of the agency. I had told Zamping that I could share it, but I got my hand slapped a bit on that. So I think we're going to have to host that in-house for now and kind of just check it as needed. But I think the results speak to this point that there's a similar level of friction between the two treatment methods. The surface defect survey indicated that after construction, the pavement appears to be in better shape. There's less cracking and less unsealed areas overall. So you can kind of see the chart there. So just a timeline on the next steps. So submitting report 4, task 4, the report on field testing is planned for February 2026. And then the draft final report and then the remaining tasks, so the last 4 tasks are June, I was incorrect, June of this year. So things are rolling pretty quickly with this job. And then we're looking at end of August for a completion date on this one. So more to come on that. And that's all. Hopefully I did that well, Zamping. And if there's anything else, please feel free to drop in the chat. And I think, Ben, I'm going to give you back exactly 5 minutes here. So
that's perfect. Thank you. And thanks for pulling that all together. I'm just going to finish up with Raul's out today and asked me just to kind of give a quick update on the Geotech team. Let me get back to sharing. And I believe you see a Geotech slide. Someone say yay. Or even a yes.
Yep.
All right, thank you.
See ya.
So these are just kind of going through the ongoing projects and the status. Again, this was a status as of TRB. Working with geotextiles for drainage. That work right now, task 5 is ongoing, but that's quite a bit complete right now, 85% complete. The flooded pavement assessment app, again, this is what will be feeding into the test section we're developing out at MnROAD. And the work we're working with the technical advisory panel for that flooded road construction. That's 70% done, along with 60% done on improving the moisture resistance, pavement foundation systems, water repellency, the work that was done on the low volume road. That one is almost done too, as you can see. And I guess you can see them as well as I can. Any comments from the team leads on those? Couple minutes. Anything above and beyond what's written there to help me out? If not, I'll go to the next slide. Again, that last one is we're working on the contract for. And some different ideas that the Geotech team has pulled together and kind of their voting. They had some voting, and again, we've talked with some of the different groups here too. So, you know, and it kind of looks at is especially with the Geotech team, is some of the different things that they might be looking at. For example, lightweight aggregates and things like that. Maybe that could be done alongside other test sections. We could build a concrete section or something if they're working in the ditch. Whereas if we're working with recycled materials and things like that, that could be done under a concrete or asphalt section. So as we kind of move towards kind of taking these ideas, and thank you to the Geotech team for ranking these and saying what they have interest in. These will be brought together and we'll have more discussions on what can be done. And again, we talked about construction. This year is kind of getting late in the year. I hate to say that when it's winter, but you know, if anything, we can do partnerships, but maybe more of the full-time, full-blown construction for the main line and the low volume might be 2027. I guess time will tell, but you can kind of see some of the ideas they had and how they were ranked, at least from this team. And they talked about priorities and needs for phase 2. You know, challenge with the area availability. I think that's a question for all of us. You know, not only for what waste material that might be after you produce a good quality material that's being demanded on a lot of our roadways, how to utilize those materials also. You know, trying to build a deep foundation that lasts long. I think that's the 100-year pavement foundations. Geosynthetics, it's always a question. Remote sensing, the substrate characteristics, projects, MWD, and deep foundations. Again, that's, you know, support for those. So again, these are some of the different things that this team has been working on. Again, I probably glossed over it quite a bit, but that gave some time for the other groups to kind of talk, at least at this quarterly team meeting. So with that, is there any questions from the group? Otherwise, again, thank you for your hard work on the teams, the team chairs, and the executive committee. Again, the executive committee will be setting up a meeting for end of February. The chairs will be talking also at the end of February, kind of working together and looking for advantages that we can take advantage of. So with that, thank you everyone and have a good rest of your day.